Maxima or minima aren't just used in sketching curves, but there are also other problems which need maximizing or minimizing. The first example is shown in this video. Welcome to differential calculus. With a square cardboard of 9 inches dimension, small squares are cut in its corners in order to make a box by lifting the sides. The task is to determine the volume of the largest box. So illustrating a square cardboard with side lengths of 9 inches, cut small squares of dimensions x by x from the corners. This will leave the base of the box with length of 9 minus twice of x. To create the box, take the base of 9 less 2x by 9 minus 2x. Then fold the sides where each side has dimensions of 9 minus 2x by x. After creating the box, compute the volume. We know that the volume for a rectangular prism is the product of the width, length, and the height. And knowing the dimensions, we can then plug 9 minus 2x by another 9 less 2x times x. The volume is then simplified as x multiplied by the square of 9 minus 2x. Learning about the volume, which is given in a single variable x, we are ready to differentiate. We can take the derivative of the function in different ways. The first option is to take it as it is and differentiate using product rule. The derivative of the volume is then dv over dx, which is equated to the first term x multiplied by the derivative of the second term, the square of 9 minus 2x. Add to this the second term times the derivative of the first. At this point, we can see dx over dx and take this as 1, leaving just 1 dx over dx from the first term. The derivative of the square of the binomial requires general power rule. So dv over dx is then the copied x times twice of the binomial with a power of 2 minus 1. Then, through chain rule, we attach d over dx of the binomial before copying the second term, square of 9 minus 2x. Eliminate d over dx by taking the individual derivatives. D over dx of 9 is 0, and the derivative of negative 2x is negative 2. Do not forget to copy the second term. With no d over dx left, simplify the function, which turns out as 0 minus 4x of 9 minus 2x plus the square of 9 minus 2x. In order to collect similar terms, take out groupings. So distribute negative 4x among the terms and also expand the square of the binomial. dv over dx is then negative 36x plus 8x squared plus 81 minus 36x plus 4x squared. dv over dx is then 12x squared minus 72x plus 81. This is the end of the differentiation. To maximize the volume, we take dv over dx as 0, making 12x squared minus 72x plus 81 as 0, and then use quadratic formula to identify x, which comes out as 4.5 and 1.5. The other option in solving for the derivative is to simplify the function first. Expand the square, which makes 81 minus 36x plus 4x squared. By distributing x among the terms, we get 81x less 36x squared plus 4x cubed. This configuration is ready for differentiation, making dv over dx as equated to 81 with d over dx of x, then negative 36 times d over dx of x squared, and then 4 with d over dx of x cubed. dx over dx is 1. So dv over dx is 81 minus 36 of 2x with d over dx from chain rule. Add to this 4 times 3x squared with d over dx of x, again from chain rule. D over dx is simplified as 1, leading to dv over dx as 81 minus 72x plus 12x squared. Now maximize the volume by equating dv over dx to 0, thereby resulting to 12x squared minus 72x plus 81 as 0. With a degree of 2, use quadratic formula to have the values of x of 4.5 and 1.5, the same as previously solved. With two x values, let's validate them first. The first is x of 4.5. Plugging this into the length of 9 minus 2x, we get 9 minus twice of 4.5, which makes 0. So x of 4.5 is not feasible. Let's try the other value of x, which was solved as 1.5. Take the side of 9 minus 2x and place 1.5 as x to have 9 minus twice of 1.5, and this gives 6 inches. Thus, x of 1.5 is feasible. Continue with taking the volume from the simplified function of x times the square of 9 minus 2x. The volume then is 1.5 times the square of 9 minus twice of 1.5, where the volume is computed as 54 square inches.